what I want you to do right now is I want you to take 60 seconds and I want you to write down everything that you remember about solving an equation. Okay? It can be the goal of solving equations, a rule that you have to follow when you're solving equations, or it could be something about inverse operations. So just take a minute and write down anything that you remember about solving equations.
What does the goal in 19 mean?
It means don't do that one.
Okay, so don't do.
Don't do those. Okay, what do you remember about solving equations? Nothing. Okay, that's very honest. Jay?
The goal is to get the variable by itself.
Good. That's exactly what the goal is. You want to get the variable by itself. You may also hear that as isolate the variable. Okay? Isolate the variable. Okay. My rule, I call the rule for solving equations the sibling rule. How many of you have a sibling? Yes, I have a 16-year-old and a 17-year-old. Now, if my 17-year-old got a car when she turned 16, what did my son expect? A car. They didn't get cars when they turned 16. But if we did, they would have expected it. If my 17-year-old got $50 for her birthday, what would my 16-year-old expect? $50. If when my 17-year-old turns 18, she gets to stay out until 1 a.m., what will my 16-year-old expect when he turns 18? Same thing. Stay out till 1 a.m. So, that is the sibling rule. And when we are solving equations, we have to follow that rule. And we write that what I do to one side, I have to do to the other. Okay, that is keeping the equation balanced. We have to treat both sides exactly the same. Exactly the same. Now, the way that we do that is by using inverse operations. We use inverse operations. So if I told you that I was going to have addition, how could I undo addition? Subtraction. So the opposite of addition is subtraction, and vice versa. The opposite of subtraction is addition. Okay? What's another set of inverse operations? Excellent. Multiplication and division. They are inverses of each other. And I heard the next one. Who said it? Good. Good. That's exactly right. Okay? Squaring a number and square rooting. Those are inverses. There's one more that we won't deal with in this class at all. You might have seen it. If I raise something to a power, so if I've got 2 to the x power, any idea what the inverse of that would be? It's logs. It's logs. Okay? Exponentials and logs are inverses of each other. We are going to be focusing on addition, subtraction, multiplication, and division. We will hit some of the square roots a little later on, but for the most part, it's addition, subtraction, multiplication, and division.
Okay, so most important is addition, subtraction.
Multiplication and division, yes. That is the most important. Good. So, here's our first one. 2x minus 1 equals 13. 2x minus 1 equals 13. So the first thing I've got to do is I've got to get that x isolated. So the way that I'm going to do that is I'm going to add 1 to both sides. And when I add 1 to both sides, I end up with 2x equals 14. Because my negative 1 and positive 1, they simplify out. I don't have that anymore. It's gone. So I'm left with 2x equals 14. Multiplication is what's happening in between that 2 and that x. So since the 2 and the x are being multiplied together, I'm going to use division to undo it. So 2 divided by 2 is 1, so I'm just left with x. 14 divided by 2 is 7. Okay? Now, it's a very, very good habit to get into checking. And the way that I check is to plug my 7 in for my x. So I'm going to have 2 times 7 minus 1, and I'm going to find out if that equals 13.
Maybe you have to check on the problems.
I would encourage you to. I'm not going to require it, but I would encourage you to. Okay, 2 times 7 is 14. Minus 1 equals 13. Does 13 equal 13? Yes. What that tells me is that x equals 7 is correct. Okay, because the check worked. Okay? This one looks a little bit different because our variable is on the right-hand side. Now, it doesn't matter which side you isolate the variable on. You can pull the variable to the right, or you can pull the variable to the left. When we start working with inequalities, you will hear me say, move your variable to the left. But it's not wrong or inappropriate if you want to just keep it, if you want to move it to the right. Okay? It will be easier when we do inequalities to move it to the left. But it's still mathematically sound to have it on either side. So because our A is already on the right-hand side, we're going to leave it on the right-hand side. So I'm going to try to get rid of that plus 9. The way that I get rid of plus 9 is I say minus 9 on each side. So I subtract 9 on each side. I'm left with negative 16 equals negative 5a. Okay? The negative 5 and the a is being multiplied together. So I am going to divide to get rid of it. Okay? Negative 16 over negative 5. A negative over a negative is a positive. Now, can 16 over 5 be simplified? And what I mean by that, is there anything that will go into 16 and 5? No. Okay? You could rewrite it as 3 1/5. That is an improper fraction of that, 3 1/5. But I would encourage you not to. I would encourage you to leave it as 16 over 5. Okay? I would leave it as 16 over 5. Just make sure that 16 over 5 is simplified. Okay, I want us to check it. I know you're tempted not to check it because it's got a fraction. But we have to deal with fractions, so we might as well continue to deal with fractions. Okay? I have negative 7 equals negative 5 times 16 over 5 plus 9. Okay? Here, I have a 5 and I have a 5. Those can cancel out. That's called cross-canceling, and that's going to be very, very important as we move through this. Very important as we move through these. Cross-canceling helps us to simplify without multiplying and then dividing. So cross-canceling is a technique that you want to be sure that you know how to do. The danger is losing that negative right there. When you cross out those 5s, you've still got a negative that you've got to deal with. So we're going to have negative 7 equals negative 16 plus 9. Don't lose the negative. Negative 16 plus negative 9 is negative 7. So it works.
What's today's date?
The 9th. The 9th. Okay? Now, for our next one, we have moved into having a variable on both sides of the equation. We have 7x minus 3 equals 5x plus 9. 7x minus 3 equals 5x plus 9. The very first thing that you want to do here is you want to get the variable on one side. Okay? And this is where I'm going to start recommend moving to the left. Just go ahead and move it to the left. You're going to be happier if you get in the habit of moving it to the left. You don't have to, but inequalities will be better if you get in this habit. So we're going to subtract 5x from both sides. Okay, so I am subtracting 5x from both sides. I'm left with 2x minus 3 equals 9. 2x minus 3 equals 9. Now I'm going to deal with my negative 3. I'm going to add 3 to both sides. And I'm left with 2x equals 12. 2x equals 12. Okay, my last step, divide both sides by 2. Okay, we are going to check this now. We're going to check. I am going to put 6 wherever there is an x. So I have 7 times 6 minus 3 equals 5 times 6 plus 9. Okay? 7 times 6 is 42. 5 times 6 is 30. 42 minus 3 is 39, and 30 plus 9 is 39. Okay? Okay. Students typically do okay with solving equations. In some ways, you may be sitting there thinking, oh, Alicia, I got this. It was that mess of stuff you made us do last week that was hard work. Okay? But sometimes students get confused with the positive and the negatives. So all that work that we did with the positive and the negatives, you've got to remember that. And one of the reasons that we have to remember that is because very often we will have to distribute when we are solving equations. And this particular problem right here requires us to distribute. I've got to distribute the 4, the 5, and the 3. So that is what I'm going to do first. I am going to distribute first. Be careful of your negatives. It's very easy to lose a negative. In fact, when I was working some of these problems today in my 10 o'clock class, I dropped a negative on the answer and it messed everything up. And I had to go back and figure out where I made my mistake. It's very easy to drop negatives. Okay, so I'm distributing. That's what I'm doing right now. So I have 4y minus 4. Now I'm going to distribute my 5. I have 5y plus 10. Now I'm going to distribute my 3. 3y minus 24. Now, my second step is to combine like terms that are on the same side. Combine like terms that are on same side of equation. So what that means is I've got my 4y and my 5y. What's 4y plus 5y? 9y. Then I've got negative 4 and positive 10. What's negative 4 and positive 10? Positive 6. So I haven't dealt with the right-hand side of my equation at all because I didn't have any like terms over here to combine. 3y and negative 24 are not like terms. So I only dealt with the like terms that were on the left-hand side of my equation. Okay? So now I'm going to get that 3y and I'm going to move it over. So I'm subtracting 3y from both sides. And I'm left with 6y plus 6 equals negative 24. I subtract 6 from both sides. I'm left with 6y equals negative 30. I'm dividing both sides by 6. What's my final answer? Good. So our third step, we isolated variable. Now, I want to check this, but before I can check it, I need to erase this right here. Is it okay if I erase the steps?
That's fine.
Okay, I'm erasing the steps. So now we're going to do our check. Your check is not required, but it is a good idea to get into that practice because it will be, especially in 144, you'll have to check for extraneous solutions. When we were talking about logs, that's one of the times you really have to check for extraneous solutions. Okay, so I am going to check this now. So everywhere there is a y, I'm going to put negative 5. So I'm going to have 4 times negative 5 minus 1. Then I have plus 5 times negative 5 plus 2. Then I have 3 times negative 5 minus 8. Okay? What is negative 5 minus 1? Negative 6. So then I have 4 times negative 6. Now the reason that I combine these two here, the negative 5 and the negative 1, is because I can. Okay? That can be simplified. When I have y minus 1, I don't know what y is, so I have to distribute. There's no reason to distribute right here. There's no reason to distribute right here. Okay? Negative 5 and positive 2. Negative 3. Okay, what's negative 5 and negative 8? Negative 5 and negative 8.
Negative 13.
You got it. Okay, 4 times negative 6. Negative 24. 5 times negative 3. Good. 3 times negative 13.
Negative 39.
Okay, and so now we end up with negative 39 equals negative 39. And that means that this value is correct. When I get negative 39 equals negative 39, that means that my y equals negative 5 is correct. Okay? Are we ready to move on to the next one? Okay. Here we go. Fractions. Fractions. Okay. What I want you to think about, if I was solving 4x plus 3 equals 11, if I was solving 4x plus 3 equals 11, what would I do first? Subtract 3 from both sides. That's what I would do. So now I have 1/2 x plus 2/3 equals 3/4. So what I want to do first is I want to get rid of that 2/3. And I do that by subtracting 2/3 from both sides. Okay? That's what I'm going to do first. 2/3 minus 2/3 cancels out. And I'm left with 1/2 x. But I need to go over here and I need to solve or simplify 3/4 minus 2/3. And to do that, I'm going to have a common denominator. What's a common denominator between 4 and 3? 12. Okay? 4 goes into 12 3 times. 3 times 3 is 9. 3 goes into 12 4 times. 4 times 2 is 8. 9/12 minus 8/12 equals 1/12. So that is what I have over here. But I'm not done. I'm not done. What if I was solving 4x equals 8? What would I have to do to get rid of the 4?
Divide it.
Have to divide. So that's what I'm going to do here. I've got to divide 1/2 x by 1/2. Okay? So when I do that, my 1/2 is gone. So I am dividing this side by 1/2. Okay? 1/12 divided by 1/2 is the same thing as multiplying by what? 2. Okay? So I'm multiplying by 2. I can cross cancel here, and my x value is 1/6. Now, that is a 100% legitimate way on how to solve this problem. It's also the more difficult way to solve this problem, and the way to solve the problem, and it has more opportunities for mistakes. So I want to show you another way to solve this problem. Jay? Okay, go ahead.
Can you, wouldn't those twos cancel each other out?
Right here?
No, in the equation itself.
Right here?
1/2 x plus 2/3. When those two.
They would not cancel each other out because that's addition.
Okay.
You are correct. If it was multiplication, they would.
Okay.
So that's a great thing that you saw. It's just that they don't because that is addition. Okay? So now I want to show you a better way to do this problem. Okay? That was 2/3, right? Yeah, that was 2/3. Now, we have already determined what our LCD is. What is our LCD between 2, 3, and 4? 12. So what I want you to get in the habit of doing when you see a problem like this is I want you to multiply everything times the LCD. Okay? We're going to multiply it all by the LCD. Okay? So I have 12 over 1 times 1/2 x. Then I have 12 over 1 times 2/3. Then I have 12 over 1 times 3/4. Now, I know how to cross cancel. Okay, what number goes into 12 and 2? 6. Okay? What number goes into 12 and 2? 2. 2 goes into 12 and 2. But when I cross cancel, 6 is what I end up with. So 6 is the correct answer. You are correct. 6 is the correct answer. But the number that's going into 2 and 12 is the number 2. 2 goes into 2 one time, and 2 goes into 12 6 times. So I'm left with 6x right here, because I do 6 times 1 times x. Now, listen to what I'm saying. What number goes into 12 and 3? 3 does. 3 goes into 3 one time. 3 goes into 12 4 times. So now I've got 4 times 2. Okay? 4 goes into 4 and 12. 4 goes into 4 one time. 4 goes into 12 3 times. Now, it is so much easier. Okay? You want to eliminate your denominators as soon as you can. That's what you want to do here. So now, this is a relatively straightforward equation that I can solve. And x is 1/6. Okay? I do want to go ahead and check this. So I have 1/2 times 1/6 plus 2/3 equals 3/4. I have to do the 1/2 times the 1/6 first. 1/2 times 1/6 first. That's going to be 1/12. Plus 2/3 equals 3/4. Okay? I'm going to change my 2/3 to something over 12. 3 goes into 12 4 times. 4 times 2 is 8. 1/12 plus 8/12 is 9/12. And is 9/12 the same thing as 3/4? Yes, it is. Okay? So, a much more straightforward way to do that one. I think you'll be a lot happier. Jay?
Like you said, I did see where, those two can cancel out and those 3s could cancel out, but it wasn't until you multiply the whole thing by 12 that I noticed, the similarities going all the way through.
Yes. Good job. We ready to try another one? Okay. This type of problem is why we solved the other type of problem the way that we did. This is when you absolutely want to eliminate your denominator. And we are going to do the same thing with this one that we did with the other one. We are going to multiply everything by my LCD. So I am looking for a number that 3, 8, and 6 go into evenly. 3, 8, and 6. Good. And so my LCD is 24. Question, Jay?
I thought you were going to multiply each one separately.
We are going to do that. Yep, we're going to do that's our next step, is multiply each one separately. Yep. So I am going to multiply this first one, 24 over 1. Now, I am going to put my x minus 2 in parentheses. And you desperately need to get into that habit immediately. Putting parentheses around the numerator. Okay? Because in just a second, we're going to have to distribute. And this fraction bar right here is a grouping symbol. That means you've got to keep everything in the top together. So that x minus 2 binomial stays together. Okay, so in my next one, my x plus 1 binomial stays together. And binomial is just a fancy word for that grouping, x plus 1. Then I've got my 5 over 6, and I am multiplying that by 24 over 1. We are going to focus on our cross cancel again. And this is where students get confused and make mistakes. This is where students get confused and make mistakes. Okay, the number that goes into both of those is 3. 3 goes into 3 one time. 3 goes into 24 8 times. So now what I'm doing is I have 8 times x minus 2. Those parentheses are what students forget. Don't forget those parentheses. Okay? 8 goes into 8 one time. 8 goes into 24 3 times. Again, write that grouping, that x plus 1, that binomial in parentheses. Okay, then my last one, 6 goes into 6 one time, 6 goes into 24 4 times. Now, we know how to solve this. Okay, we distribute, we combine like terms. So I have 8 times x, 8 times negative 2. 3 times x, 3 times 1. Okay? 8x and 3x are my like terms, as are negative 16 and positive 3. Negative 16 and positive 3 give me negative 13. I add 13 to both sides. And I'm left with 11x equals 33. Okay, I divide both sides by 11. My answer there is x equals 3. X equals 3. Okay? This step right here to this step right here, that's where sometimes students get lost. Okay? Now, in order for me to show you the check on this one, I need to erase. Is it okay if I erase? Can I erase now? Okay, so x equals 3. So I'm going back to my original problem, and everywhere I see an x, I'm plugging in a 3. So this is my check. 3 minus 2 over 3 plus 3 plus 1 over 8. Okay, 3 minus 2, what's 3 minus 2? Good, so I have 1/3. 3 plus 4, or 3 plus 1 is 4, I apologize. That gives me 4/8. Now, 4/8 is the same thing as 1/2. Okay, so 1/3 plus 1/2 equals 5/6, and it does, because 1/3 is the same thing as 2/6. 1/2 is the same thing as 3/6, and that equals 5/6. Okay, I've got one more. One more. Can I go to the next one?
Sure.
Okay. 3t minus 1 over 5 minus t minus 4 over 3 equals 1. Okay? This is one of the ones that's challenging to students. The reason that it's challenging to students is because of that subtraction sign. I like to deal with that subtraction sign first and get it out of the way. I just want to know that I've dealt with that subtraction sign. So what I do is I take that minus, I turn it into a plus, and I give it to my numerator. But I have to give it to my entire numerator. That's why those parentheses are so important. Okay, so my entire numerator is negative. Many of you will want to put a 1 right there so you can think about it as a negative 1. Dealing with it then is the best thing that you can do. So I've dealt with that subtraction. Now, what's my LCD? 15. So I'm going to multiply everything 15 over 1. So 15 over 1 times, I'm putting my 3t minus 1 in parentheses. Then I have 15 over 1, and I am multiplying that times negative 1 times t minus 4. Okay? Then that is equal to 1 over 1 times 15 over 1. Okay, let's deal with making this a simpler problem to solve. 5 goes into 5 one time. 5 goes into 15 3 times. So now this is 3 times 3t minus 1. Okay? 3 goes into 3 once. 3 goes into 15 5. But look, I've got 5 and I've got a negative. What's 5 times negative 1? Good. So I am distributing that negative 5 to t minus 4. That negative is what causes students fits. It's that negative. Okay? So be careful with that negative. Don't drop it. 3 times 3t is 9t. 3 times negative 1 is negative 3. Then you've got minus 5t. Negative 5 times negative 4, positive 20. Okay? 9t and negative 5t is going to give me positive 4t.
That kind of sounds like 4D.
Yep. Okay, then I've got negative 3 and positive 20. Positive 17. This is where I messed up in my last class. I subtract 17 from both sides. When I say 15 minus 17, what do I get? Negative 2. I dropped my negative in my last class because I was working too fast at the very end.
Hold on a second.
So I have 4t equals negative 2. I divide both sides by 4, and my final answer is t equals negative 1/2. Okay, I'm not going to check it because of time. Okay, but the answer here is negative 1/2.